Students came now. Sam, from down. From down. Okay, starting the session, please. Let's start the session. So now look here. We are going to study today about Galileo. Before that, we were discussing about force. In the concept, when we were starting about force, we discussed some very important thing. Deva, hello, beta. Hello, hi, how are you? Good afternoon. Let's see everyone join as fast as possible so that I can start the session quickly. Good afternoon. Now look at last class we were discussing about very important section we discussed. So in that section today, first I'm going to give you revision. Just let's see. Okay. Huh. Beta, can you write your name so that it will be easy for me to find? That will be easy for me. If you write your name means it will be very easy for me. Huh. Because forgetting name is my very bad habit. Now, children, listen. So, I'm starting the session, please. Last class, we've understood about force. In that, we understood that force is nothing but a type of push or pull. It can change the shape, it can change the direction, it can, Tanisha, I know Tanisha, your name I'm knowing. Anushya, that name is little difficult, so I'm forgetting that name. I'm sorry for that. So, I'm going to the content, please. So, we have understood a very important thing in the previous part, that force can be balanced and unbalanced force. In that we discussed that if a force is Arunisha, so if a force can be better balanced, means the object will be in the state of rest or it will be in the state of uniform motion. So if it will be in the state of rest, it will not change its state of rest until and unless an external force is not applied on it. Right? Until unless an external force will not be applied on it. Understood? And if it will be in uniform motion, that it will continue its uniform motion until and unless an external force is not applied on it. So these things are some of the most crucial point about force. Understood? That we have already studied. Now today we are going to understand about Galileo's observation. Now children, what is here about Galileo observation? Kanish, I'm going to start with Galileo observation and I'm going to explain about Galileo observation. So what in all, good evening Siddharth. So here, what in all are there for Galileo's observation? Let's check this one out. Okay. So now first thing is, for his experiment, what, Chahil, good evening beta. Good evening Chahil. Very good. So now I think all the children are in time. I am also in time today. So now look here. So session has started. Now with a Galileo concept I am going to teach today. So first I am going to ask one question. We have learned about force. We have learned about change in shape, size, direction, everything. And we came to know something about, exactly when we were discussing, we came to know something like कि when inertia will be there, changes will not be there. Inertia is the incapability of a body to change its state of rest or motion until and unless an external force is applied on it. So we came to know that. But beta, one major crucial factor we have missed. Understood? So the missing crucial factor, we are going to cover it up. So what crucial factor we have missed? Now let's cover it up. For this, Galileo has given an experiment. Now the experiment, please now take out your note. If you are not writing, the video you need to check. Understood? So what is the rule here is, the video will not be there for long time. This video will vanish because I'll make it private. Okay. At the time of teaching, after 1 week, the video will not be there. So within 1 week, you write everything in the notes. Understood? This notes will be specifically provided to you also. Now come on, go for it. Let's get back to the work. Shall we start our work? So Galileo's observation we are going to discuss. So Galileo was a great scientist. He disagreed with Aristotle, who said that body needs continuous force to stay in motion. Instead, see, look here. Body needs constant force. Body needs what? Constant force to continue the state of motion. This was not given by Galileo. This was not given by Newton. It was actually given by whom? It was given by Aristotle. And Aristotle said that you need to give a constant force for a body to continue its motion. What you need to give? A constant force to a body to continue its motion. So this concept was given by whom? Aristotle. So Galileo has disagreed with the fact and he told that no, this is not actually the truth. Understood? So now what is the case here is we need to understand this part with much understanding. So now look here, an object will continue to move with the same speed and direction until and unless an external or unbalanced force is applied on it. This is exactly given by Galileo. So Galileo told that if a body is at rest, it will remain at rest. If a body is at motion, if a body is at uniform motion, it will remain at uniform motion until and unless an external force is applied on it. That means what? You need to apply an external force. What you need to apply, beta? You need to apply an external force. So that external force is the driving force which will allow the body to move. It will allow the body to move. But that force will be balanced or unbalanced, we need to understand that. So the Galileo has given a concept and he has exactly proven everything with an experiment. So now let's check the experiment. External force, yes, Galileo told that a body will be at rest means it will remain at rest. A body will be at motion means uniform motion means it will remain at uniform motion. There no external force is needed. What is not needed? External force. Like our earth, one simple example I'm giving you. Our earth is exactly rotating, understood, on its axis also, and it is revolving around sun also, understood. So when our earth is doing the rotation and revolution, it is doing in a perfect pace with time. No external force is needed for it, understood. So this concept he has given the name inertia. But how he has proved this? He proved with a very important, unique experiment. So let's check the experiment out. So first we are going to see the experiment. What he did is, this is exactly the base. Understood? Now this is the floor. Now first what he did, he kept equal inclination. Now look at it, this is equal inclination. So one plane equal inclination means if this and this inclination is same, so height remains the same. Understood? Now understand the concept very nicely one by one. So here first one what he did is he took a ball, understood, and then from this height SH he allowed the ball to roll. Understood? So at the time of rolling, what the ball will experience? The ball will experience increase in speed. Why? Because it's an inclined plane. Na? So definitely here increase. So here theta and this is theta 1. Understood? So at the time when it is rolling, its speed is increasing. Got it? And it is exactly fulfilling the demand of the gravity. Okay, Dash. So now look at it up. So what happened here is, just understand nicely, its speed is increasing and gravity was there. So because of gravity increase, what? You're going towards gravity. 100% speed will be increasing. Understood? So one time came when it hit this area and after hitting, it started sliding up. So till where it will go? Till where it will go? Because both are having the same height, you will be seeing it will reach to the same height and it will cover the same distance. It will reach to the same height and it will exactly cover the same distance. So here what we have experienced and what we have learned, good evening beta, good evening Bhavya. So what we have seen here is when theta is equal to theta 1, the ball will be exactly rolling and it is covering and it is reaching the same height. Understood? So distance covered remains the same. Distance covered remains the same. Good evening, beta. Good evening, Sanskar. So the distance covers remains the same. The distance covers remains the same. Understood? And it is reaching the same height. Got it? Now we have understood one thing, that when inclination is exactly coming same height reaching, same distance covering. Okay. Then what about if we change the inclination? So if we are changing the inclination, now we are reducing it. So here theta, you see here this is theta. The inclination angle I have reduced. Understood? So what I am doing here is I am just changing the inclination angle. So if I am changing the inclination angle, can you see this? Huh? Now it has to cover some distance here, correct now? So now what will happen? It will roll down, but it will reach to that height, correct? It will roll down and it will reach to that height. So after rolling, it will again go and it will attain the same height. Bingo. That means what? Here again it is reaching to the same height. Again it is reaching where, beta? It is reaching to the same height. So we understood one thing, though the inclination angle changed. First inclination angle was theta and theta is equal to theta 1. But this time it is not the same. This time theta is greater than theta 2. Got it? So this angle theta 2 for the new one is a smaller. This inclination angle is smaller. And slowly, gradually, Anuj, good evening, beta. Slowly, gradually, this is exactly decreasing down. Understood? The slope we are changing. Look here, beta, the slope we are actually changing. But one thing we are seeing, that the displacement covered, because of change in the slope, the displacement or the distance covered will be increasing. What is increasing here? Distance covered. But it will try to reach the same height. Where it is reaching, it is trying to reach the same height. But beta, when I will allow it to go slide down, then what will happen? It will slide down, and it will cover some distance. Understood? So we understood a very important thing. What is that conclusion? What Galileo has drawn is कि if, listen very carefully children, if we are applying any external force, the external force won't stay in the body for long time. The external force won't stay in the body for long time. The external force, what is not there? It is not staying in the body for a long time. It will compensate and it will exactly finish out. Until the external force will be getting over, again the body will come in the state of rest. Understood? So this has proved a very important point. It proved the most important point, that if a body is at state of rest, it will stay in the state of rest. If a body stays at the state of motion, it will stay in the state of motion. Understood? Won't stay in our body long time. Yes, it will be exactly, beta. What will happen is it will stay in the state of rest or it will stay in a state of motion. Okay. State of rest and state of rest or state of motion. Understood? So if any external force is applied, means it will stay for some time. Once the external unbalanced force is going to be over, the body will again attain its state of rest. Like I am going to give you a ball, you will roll the ball will be exactly rolling for certain time, and after that, once the external force, the force which is applied on the body, that ball will be over, it will be exactly going to stop. It will again come in the state of rest. Understood? Stop sleeping, huh? Wait. So that is exactly, it will come in the state of inertia again. Where it will come? It will come again in the state of inertia. Understood? What is inertia? Inertia is the incapability of a body to change its state of rest or motion until and unless an external force is applied on it. Got it? So now let's see. We will go for the next one, please. Wait, First, I will wake you up by certain questions. Let's do some questions. Let's see who is going to answer first. Huh? Which of the following is not a force? Magnetic pull, friction, gravity, and temperature. The correct answer is temperature. So option D is the wrong answer. Means wrong means according to the question, it's the correct answer. Go for the next one, please. Come on, wake up. Okay, online children has given some answers. Let's see offline children what they have to say. Come on, say. Which of what is the direction of force of friction? Friction is opposing motion, so it is going to be opposite to motion. I hope you might have understood. It is opposing the motion. So let's go for the next question, please. That is option number B. That is what option? Come on, write down fast. Do it fast here, please. So now look here. Force and now look here. Force can only stop a moving object, only change the shape of an object, change the state of motion and shape of object, only move object. See? I. Think first. Force can? Force can move the object. Anything else? Answer is? You have some time. Come on, say the answer fast. Now look here. First is force can only stop a moving object. It can only do that. We know that force can do multiple work. It only change the shape of an object, change the state of motion and shape of object, only move object. So which is the most primal? The answer is C, because change the state of motion and shape of objects. That's the most accurate answer. That is option number C is more correct answer. Correct? Very good. So only I was smiling. Huh? Now look here. Now a Newton is what? So we didn't reach till here, but it was enough to wake you up, Amrish. Huh? 1 kg, 1 meter per second square. What is the correct answer? Okay. Inky, Pinky, Ponky, father had a donkey. Huh? Nice. The donkey is you only, huh? D. A. No. Newton is meter per second square. See, first understand force is equal to A. First we will understand. Physics means what? Whatever we will say means it will come correct. No, not possible. So now look here. Force is equal to mass into acceleration. Okay. Force is equal to mass into acceleration. Mass unit is kg, acceleration is meter per second square. So it will become kg meter per second square. So answer is first one. Understood. Answer is first one. Okay. Yes, absolutely correct, Aru. Answer is first one. Answer is first one. Huh? Now we'll go for the next one, please. I. Newton. Huh. Newton first law of motion that day I have discussed. Newton first law of Newton first law of motion is called as acceleration. But acceleration we can't say. See, Newton first law of motion is acceleration, force, action and reaction in inertia. What is the answer? The correct answer is inertia. So Newton law of motion is also called as law of inertia. Now you are active. Wake up, please. Now you are okay. Now can we go back to our work? For you only I started MCQs because you are very nicely sleeping. I was feeling bad also, but it's like okay, fine. I should do some things that you'll wake up. So now we are going back to our concept of Galileo. Sorry, English is very nice, seriously. Now look here. So that means what we are going back to the concept where Galileo has told that key for letting a body change its state of motion or rest and come into unbalanced force, because if something is moving with balanced force, it will remain at balanced state. If something is moving with what you call, if something is kept at rest, it will stay at rest until and unless an unbalanced force or external force is applied on it. But this external force will temporarily change the state. After some time, it will again come to rest, or it will again go to its initial motion, uniform motion state. I hope it is clear to you. So here, an object will continue to move with the same speed and direction until and unless an unbalanced force is applied on it. And this is exactly Galileo's experiment. So he rolled a marble and did the experiment already. I'm fine, thank you, Munib. Now listen. So the ball rolled down. How are you, Munib? So the ball rolled down fast, gaining speed. So that already we understood. When we are sliding down, the speed is exactly increasing. Understood? And once it is reaching down, again it is exactly putting momentum and it is going up. Till where it is going? Till it is not attending the same height and same distance it is covering. Understood? So that's the content. Yes, MCQs are nice. For that, we have to study now. Then only we will go back to the MCQ. So Galileo was telling, but here one thing we must remember. One thing we must remember till that point. Here we were taking frictionless surface. We did not discussed about that. So I'm explaining you what slide we are making now. That slide will be frictionless. Understood? What that slide means, the inclination plane what we are taking, that inclination plane must be frictionless. If friction will be there, then it will impact on the marble and maybe the speed of the marble will get affected. I hope you might have understood. The planes what we have exactly taken, it has to be frictionless. That's the most crucial point we must remember there. So only an unbalanced force is needed to stop or change the motion. That's one of the important thing. Okay. Aru, I'll go back to that here. Why you are thinking? An object keeps moving with the same speed if no unbalanced force act on it. This idea helped in forming Newton's first law of motion. Yes, our Newton first law of motion. Who is the big person? Yes, Lokesh, I know that most of the concept what we are studying, we'll discuss about it. We'll have a very big discussion about it. We'll have a very big discussion next class. Huh? Come in time. Okay. Come before 5 minutes of your class. That will be more better. Okay. Bye. Yes. So the thing here is we are understanding. See, there is nothing called as uniform motion, something, because you can't maintain uniformity. Correct, na? For a long distance journey, just imagine you are moving in a highway. Correct. So when you are moving in a highway and cars are coming, now you are thinking I'm going to follow Newton, means definitely that day nice everything can happen, huh? So you will land to hospital only. So what is there is uniformity can be maintained for a shortest distance. Understood? So that will be exactly the correct application, correct definition, but for application we can't be like that. Okay, now can I go back to the topic, please? The idea helped in forming Newton's first law of motion. So what is Newton's first law of motion? Come on, those children who are exactly present online, can you say what is Newton's first law of motion? What is Newton's first law of motion? Online, offline children also you can answer. Rather than sleeping, you can answer the question. Come on, say. Go for it. In Newton's first law of motion is only inertia. And what is inertia? Baba. Come on, type and say. Huh? Whatever will come in mind, I have to vomit. After that, we'll see. It is correct or wrong. Kanish, what is Newton's first law of motion? Inertia. It's like eureka, eureka, inertia is there. We will answer only inertia. Come on, type and send me the answer. Children, online children, type and send me the answer. Inertia. Super. Huh? Class? Ah, very good. So super. What we are going to do, beta? Last class we have studied that Newton has exactly given three laws. First law is also called as law of inertia because inertia is the incapability of change of a body when it is at rest, it will remain at rest. If it is in motion, it will remain at motion. And if it is moving in a specific direction, it will keep on until and unless an external force is applied on it. Understood? And that last class we have studied now, correct Sam? In last class we have studied about inertia and it was exactly connected to Newton also, correct now? Now beta, we are going to understand some of the concepts. Can we talk about it? Can we talk about it? Last class also we have discussed some examples. I talked about one thing, change in state of motion. That's absolutely correct. Now, last class we were talking about one, what you called, bus. Bus was at rest and suddenly the bus will start. Where you will be, forward or backward? Why backward? Why not forward? Why backward? Means if the bus will start, means the bus will say, no, you have to go backward. Wow. Bus is moving, but your body is at rest. Bus is moving. Your body is first is in contact with chair, and yes, the leg is in contact with the floor of the bus. Understood? Now suddenly the bus will start. When the bus will start, what will happen? Yes, it is going backward direction, but what will happen if the bus will start suddenly? When the bus will start suddenly, one thing will happen, that is the lower part, means the leg which is in contact with the floor, because the bus is in motion, that half part will come in motion and half part is still at rest. So what will happen? Backward direction, correct? Now second concept was carpet problem. What was the carpet discussion we have done? Huh? What happened, gamer beta? Huh? See, that was exactly I have discussed about it. I have discussed about the carpet. We have discussed that the carpet, dirty carpet is there. We are going to hang the carpet and we are going to beat the carpet. So when we are beating the carpet, what will happen? When we are beating the carpet, what will happen? See, which one will come in motion and which one is still at rest? See, the carpet will be at rest. After beating the carpet will be at rest. Kanish, which one will come in motion? Come on, children, online children, tell me which one. First, you go and put that live button so that you will be with the pace. Okay. So, which one will come in rest and which one will still be in motion? When you beat the carpet will come in motion and the dust particle is still at rest. So, where it will go? It will fall down. Understood? Again, we have discussed about another important point, that the trees having fruits, mangoes. What we are going to do, if we will shake the trees, what will happen? What will happen? The tree will come in motion, the fruits are still at rest, so it will fall down. Understood? So that's the concept we have discussed about. Yes, dust will be in rest, so it will fall down. Correct, absolutely correct. Now a bullet fired from a gun makes a small hole in a glass window pan. Understood? But a while passing through it, but if a stone will be there, it will not be doing like that. But if I am going to throw a stone, what will happen? I am just asking the question one more time. That's absolutely correct. Super. Mango will fall down. Ah, gun is releasing a bullet. The bullet is crossing a glass piece. Okay, it will make a small hole in the glass piece. But if I'm taking a stone, the glass will break or it will also make a hole. That time also. It will break. What is the difference in that? Force is absorbed. So force is getting absorbed. In bus case, due to inertia, the bus passenger are backward. Wow, you are so fast. After we change the concept, you are discussing about the concept. Come on, go for the next one. Huh? Say correctly. Anyone online? Come on, say the answer. No, I am not agreeing with the concept, please. Glass will break in which situation? That's what I'm waiting for your reply. Glass will break in which position? Which situation the glass will break? See, concept is simple. We are going to work on it. Huh? A glass is taken and is kept straight. Now, when the bullet is exactly, the glass is fixed, just like the window glass. Huh? Now it is fixed. It is closed. Now with bullet, exactly now the gun fired the bullet. The bullet is going and hitting the glass. Now what happened here is only one small hole happened in the glass. The glass did not broke. Understood? Why? Because only a small portion of, because the speed is very fast. Understood? The bullet speed is very, very fast. Understood? The bullet is moving with a very fast speed. Second, only the few portion of the particles of the glass got disturbed. Their inertia will be disturbed. He told. Yes, so speed is one of the crucial factor. Correct. Absolutely correct. But when the stone will be exactly hitting, see, stone will be hitting, the stone speed will not be that much. Understood or not? And it is disturbing the inertia of lots of the particles that is present. So speed is one of the crucial factor associated with it. Okay. Because of less speed. Absolutely correct. Because of less speed. So we discussed about inertia. Now look here. Inertia of rest we have discussed. Now we are going to discuss about inertia of motion. We have already discussed. Now let's just one small thing I need to discuss. I am carrying a bag in my hand. Is it inertia of rest or inertia of motion? How many of you are agreeing, online children? Is it inertia of rest or inertia of motion? Inertia of rest or inertia of motion? Inertia of rest or inertia of motion? Is it inertia of rest or inertia of motion? Inertia of rest. Same luggage if inertia of motion you are telling. Luggage in hand, Bhavya. Tanisha, luggage in hand. It's rest. Absolutely. It will come as inertia of rest. That's the most important. Correct only. Inertia of rest. If the luggage is in your hand, it is inertia of rest. So here the body will be, see, because the force is nicely balanced now. The force is balanced. That day I discussed now from how many sides force are exactly getting balanced. Up, normal, down, gravity. And here left and right, two force balanced. And so here it is hanging now, so it is exactly balanced. So inertia of rest is there and it is balanced. But same time, if the bag will be dropped from the hand, that time will it be balanced or unbalanced? That time will it be inertia of rest or inertia of motion? Inertia of motion. Absolutely correct. So the idea helped in Newton's first law of motion. Let's talk about it. Galileo experiment already we have done. This was Newton's first law of motion. A book lying on a table, examples, let's see. A book lying on a table stays there until and unless an external force is not applied on it. A ball keeps rolling unless friction or a wall stops it. Understood not? So that means what? If a ball is rolling on a frictionless surface, will it roll or it will stop? It will roll. It will not stop. Why? frictionless. But if the same ball will be rolling on a frictional surface, then it will stop. Understood? If it is rolling on a surface which is having friction, after some time it will stop. Very good. A car suddenly stop, but passenger fall forward due to inertia of motion. Car suddenly starts backward, stops forward. Understood? Because car is exactly in motion. Correct now? The car is exactly in motion. The down part of the passenger which is in contact with the surface is in motion. Suddenly what will happen? Car will stop. Then what happens? Yes. So exactly now it will come forward. Why it will come forward? Because suddenly the downside is coming at rest. Understood? So the impact will be the passenger will be falling forward. A bus suddenly, that's something we have already studied. So due to inertia of rest. Now we are going to understand the next one. So this is exactly the concept of inertia already we have discussed. So this idea comes from Newton's first law of motion already. Newton's first law of motion is called as law of inertia. So we are just sliding and checking what and all we have already covered. Okay. So a body at rest wants to stay at rest. A moving body wants to keep moving at the same speed and direction. Until and unless we are going to apply what? External force. So we need an application. It does not change its state until and unless an external force is applied on it. So what is inertia? Inertia is the natural tendency of a body to resist any change in state of rest or motion. So it's a natural, yes, it is a natural tendency of the body. It is what? Natural tendency of the body. That is exactly considered as inertia. Come on, note down please. Okay, sir, I am waiting for you. Over. It is a natural tendency. What is it? A natural tendency of a body to resist any change. It is resisting change. It is resisting change. Now we'll go for the next one. So second law of motion. Can we understand second law of motion in much detail? In second law of motion, we are going to talk about momentum. We are going to talk about momentum. Momentum is mass into velocity. What is momentum, beta? Mass into velocity. For momentum understanding, now let's take some example because sorry, because real physics is in nature. Real physics is not everywhere. It is in nature. So suddenly, what happens? Just understand this part. After that, we'll discuss. Okay. One thing I'm going to discuss with you. Just give me an answer. I am paddling a cycle. Another cycle came in front of me and we both had accident. Understood? Now I am paddling a cycle. A bus came in front of me and we had an accident. Which one? Cycle will fly, I know. But which case the cycle will fly in more case? First case or second case? See, I'm repeating my question. I'm repeating my question. I am paddling a cycle. I'm just cycling, and suddenly a cycle came in front of me, which is a natural thing. So, accident. That's okay. One case. Second case is I'm cycling. Bus came in front of me. An accident happened. Which one is more impactful? Tendency means, yeah, tendency means it's the nature. Okay, it's a whole sort of nature and behavior. Motion. Anurag, this question I'm just asking from everyone. I just asked one question from everyone. I asked that, okay, if a cycle is going to dash with another cycle, or a cycle or a bus will have accident, meeting, collision, what we can say, where impact will be more, and which one will have more damage? Second. I will be here, cycle will be here. I will be in. So question is this one only. So I'm just discussing with them. So now can you explain this part? Why is it due to momentum? Is momentum connected with it? Because my question is not cycle is going to be survive or not, or bus is going to survive or not. Definitely one cycle is there and bus is going to dash, means bus will not have that much damage. The damage will be for cycle. Two car collision means damage will be exactly equal, but little bit more on the higher side for what which is exactly coming. Understood? So here we need to understand one thing. When we are talking about collisions, cycling will be the first case. In first case, damage will be less. Understood? Both will be survived. But in the second case, one will be Govinda Govinda. Why? The one on bus, sorry, the one which is exactly inside bus, the passenger inside bus, or the one which is in cycle. Def- that will also not damage because my mistake, I came towards the bus. Correct now? I will be going. Correct only. I will be only going. See, listen, understand here. The physics says that it is exactly due to momentum. Momentum is mass into velocity. The one which is having higher mass, it will have high velocity. Understood? So when any object will have more mass, like you will just throw a ball on me, I will nicely catch and I say out. Correct. If you will throw a stone on me, will I stand on that side? Yes, see, idiot. I will not be standing at that place. You will stand and catch a stone. You will stand and catch a stone. After that, we have to. After that, we have to send you to hospital. Correctly. Small stone also, you will definitely don't dare to go and catch because it will hit you very badly. See, not only momentum, shape of the object is also very important. Your mother will throw household items, utensils, you will definitely don't dare to catch because the shape is not even, right? So when somebody will be throwing you a ball, 100% you know that the edges of the ball it is not having edges, it is circular. So it is less dangerous to you. Your mind is exactly perceiving like that only, na? Huh? That he is mental, you are also mental. So only, correct only, Bhavya. They are telling that the three people will try to stop the stone. First time I am hearing, they will be trying to stop the stone. Mahabalipuram one stone, the stone is hanging now. You just correct only. So the correct answer will be it is due to the mass and velocity. Higher the mass. So definitely if somebody will tell you to push a bike, very nicely you will push the bike and you will say I am Bahubali. But if somebody will tell you push the truck means you will say okay 5-6 people or many people are needed to push it. Why? Yeah, Ayushi from Uttar Pradesh. Okay, fine. One person has. Okay. Ayushi from Uttar Pradesh, thank you so much for making science so interesting and easy to understand. Your teaching style on Amaya channel is just amazing. Thank you so much. No need to clap. It's my duty only. Okay. Correct only. So, hey, momentum we were understanding physics. Better understand one thing. Real physics is not inside book. Real physics is in nature, and from nature only we have captured the formulas and we have interpreted. Okay. Hello, Simon. So now listen, everyone. I hope you have understood this one. So the second law of motion, which is exactly given by Newton, it is discussing about momentum. Understood? And momentum is nothing but mass into velocity. So beta, we need to understand that if a body will be having more mass, it will have more velocity. Got it? So a ball and a stone, both will be sliding. The one which will have more mass will have more velocity. Stopping it will become little difficult for you, not little, more difficult for you. But ball stopping is easier for you. Understood? Thank you so much, Ayushi. God bless you. Now look here. So we are going to talk about in that Force is one of the most important thing. Force is equal to mass into acceleration. Understood? So what is acceleration? I forgot what is acceleration. And what is mass? Hi, Simon. Learn, beta. Learning is not about classes. Learning is about what you're understanding. The concepts will always be helpful. What is mass and how it is different from weight? Hey, mass means mass and Jupiter, no. What is mass? Today they are making fun. What is mass and how it is different from weight? Will my weight be everywhere same or my mass will be everywhere same? Which one will be same? Come on, children. V minus U by T is equal to acceleration. That's absolutely correct. But I want to understand one thing. What is the difference between mass and weight? First, give me this answer. What is the difference between mass and weight? Ma'am, what is the difference between mass and weight? Very good. And mass is not mentioned as weight, kg? Pa. Actually, mass and weight are not same. First understand that. Yes, mass and weight is not same. Mass and weight is not at all same, they are different. Okay, mass and weight is not at all same, they are different. Rate of change of velocity. Manju, good evening, beta. Come on, go for it and give me some concrete answer. See, I asked and I'm going to answer this question. Weight is force into gravity. Mass is density and volume. So according to the particle composition of the body, there will be a density and its volume. And accordingly, mass is measured. Understood? Wherever we will go in any part of the universe, our mass remains the same. Understood? Because mass is independent of gravity. Mass is totally dependent upon the particle composition of the body, and the second part is particle composition of the body and its density. Got it? So density and particle composition. Density and particle composition. So you need to understand one thing, that mass is not going to change because it is totally dependent upon the particle. You cannot change the particle composition of the body. So it will have a specific volume and it will have a density. So mass, if you are in here, or I will throw you on moon, or I will send you in any other planet, your mass remains the same. But what will change is mass is a scalar quantity. Yes, mass do not have any what you call direction. It will have only magnitude. So since it will have only magnitude, it will have no. So SI unit of mass is kg. Yes, but SI unit of weight is not kg. SI unit of weight is not kg. SI unit of weight is Newton. That you must remember, because weight is force into gravity. Understood? So if I will be in a 50th storied building, or if I will be on a higher altitude, definitely my weight will change, because how much I will go away from the surface of earth, because that much my weight will vary. Understood? So on the surface of earth or above to certain height, my weight do not remains the same, because weight is exactly mass into weight is exactly what, beta? Weight is mass into gravity. And according to the gravitational pull of any planet, the weight will change. Understood? So now in Mars, my weight will be different. On Earth, my weight will be different. Or any other planet, if I will go for a vacation, my weight will vary. In Moon also, sorry, on Moon also, my weight will be different. I hope you might have understood this concept. Inertia of direction means if a specific rotation or somewhere the body keeps on changing the direction with a regular pace, it will keep on changing with the same pace, with the same speed, it will keep on changing. until and unless an external force is until and unless an external force is not applied on it. Understood? That is called as inertia of direction. I hope you might have understood this one. Come on. So we have understood the concept of inertia. We have little bit just introduction I started about momentum, and we understood one thing. It's the mass. Will is mass and weight same? Is mass and weight same? No. Okay. Mass will remain constant everywhere, or weight will remain constant everywhere? Mass depends upon, come on, come on, come on, very good. Mass will remain constant everywhere. That's the cool answer. But will it remain same everywhere? Come on, say. Will it remain same everywhere? Yes. Mass depends upon what? Mass depends upon density and volume. The particles which will be constituting a body or a matter, that will be exactly responsible for giving it a particular volume and shape. Understood? According to the particle composition, its intact position, it will be having density. Understood? And since it will have a specific density and volume, it will have a specific mass. Understood? So mass remains same everywhere. One brick I will take here on earth, or one brick I will take on moon, the mass of the brick will remain the same, but definitely its weight will change. Understood? So here whatever is there on moon, it will be 1/6. Okay, so if you are here 60 kg, what will be your weight on moon? 30 kg. How? Whatever. 4 or 5 kg. No, I am not born itself. Correct. No, mass depends upon density. Absolutely correct. Yes, momentum is what, beta? Momentum is mass into velocity. Understood? So here momentum totally plays with what is the mass of the body. Accordingly, if you generate an external force, just like I have a stone and that stone is having mass. So I gave some external, heavy external force, and I change the mass. So once I change the mass, sorry, I change the velocity. Hey, don't talk. Once the velocity is generated in the body will keep on moving because its mass is heavy. We can't stop it. Okay. Fine. I hope you might have understood these concepts. I am going to next class. I am going to talk to you all about inertia, and then how we are going to derive the force formula F is equal to ma. Understood? And we will solve some numericals. Bye everyone. Constantly calls are coming. What is this?